Welcome, everyone. Welcome to another edition of DevOps Unbound. It is the all things DevOps show that we do here at Techstrong on Techstrong TV. And DevOps Unbound plays about every 2 weeks, and we usually have a recorded panel of amazing guests talking about all things DevOps. However, once every 2 to 3 episodes of DevOps Unbound, we do something a little different. We do a live roundtable DevOps Unbound where we invite our studio audience in. And studio audience, of course, is a relative term. You're not here in a studio, you're all over the world. But we invite our audience in to participate in our discussion. And the way you participate is we do use this big marker broadcasting system. It plays in most of your browsers. And for most of you on the right-hand corner of your browser screen, you will see the big marker communications panel, which includes chat, QA, polls, and handouts up top. And we use primarily the chat and QA here. Under chat, there's public chat, which is just that, public. If you type in there, everyone, including the other attendees of today's webinar, will see what you wrote. And if you want them to, by all means, have at it. As you can see, some of our panel folks are already resting it, typing in the chat and welcoming our guests in here. I always like to just get things started by saying, hey, if you're here, do make sure your chat works. Log in, give us a hello from wherever you are in the world. It's always a kick for me to see what a global audience we usually get here. And we already got some folks from Vancouver and Denver and Caracas, Venezuela, and Colorado and Brazil. I love Brazil. Venezuela, welcome from Caracas. Anyway, but more than just telling us where you are, if there's a topic or a question, or you want to, it doesn't have to be a question, it could be a comment. Please let us know, type it in there and we will answer it. Other audience members may answer it. We'll bring it up to the panel. If you have something, though, specifically for our panel that you want our panel to discuss, I encourage you to use not the chat part of the communications window, but go to where it says Q&A, and it's probably grayed out until you click on it. But when you click on that, you can type your question right in there. And that won't go to everybody, right? It won't go to all of the people attending the webinar. It'll only come basically to our panel members, and we'll raise that up to the panel and see what we have to say about it and stimulate the conversation. Now, I mentioned we've been doing this for about 3 years. Since day one, our friends at Tricentis have been kind enough to sponsor DevOps Unbound. We couldn't do this show without them. And so just a big shout out to Tricentis, worldwide leader in continuous testing, for helping us and sponsoring this show. And it's more than just sponsoring. They're deeply, deeply involved. Lanier Norval is our Tricentis co-producer, and she's involved in helping us pick the topics and the guests and just everything from, picking out the silverware to the menu. So many, many thanks to Lanier and the Tricentis folks. Today's session is amazing. We've got an amazing panel I'm going to introduce you to in a second. But today's session deals with observability. And it's observability has many facets to it, as our friend Jency is going to lead us off with. But we're going to try to focus a little bit today on what I call kind of the shift left aspect of observability, using observability in pre-deployment scenarios in your testing and development cycles for observability driven design. And what does that mean, right? Observability itself is a fairly new term. It's really exploded on the scene in, let's say, the last 3 years, maybe 4 years. And we're going to talk about a lot of that stuff. And I couldn't think of better people to have us talk about. Let me introduce you real quickly now to our panel. Leading off, I'm happy to have, she's a returning panel member. She's I don't know, somehow we tricked her into coming back again. But let me introduce you to Adriana Villela. Adriana, if you wouldn't mind telling our audience a little bit about yourself.
Yeah, sure. Thanks for having me again. Super excited. So I'm Adriana Villela. I am in Toronto, Canada, originally from Brazil. Been in software for 20 plus years, 16 years of it been as a Java developer, now in the DevOps SRE observability space and doing what I love, which is a developer advocate at ServiceNow Cloud Observability, which you may have heard of before as Lightstep. And I'm also heavily involved in OpenTelemetry.
Excellent. Excellent. Next, I'd like to introduce you to Brian Cole. Brian, if you wouldn't mind sharing your background.
Yeah, so good morning, good evening, good afternoon, everybody. My name is Brian Cole. I work at Tricentis as the Director of Customer Engineering for Neoload, a performance engineering solution. So this topic is near and dear to my heart because adding observability and monitoring solutions into a quality practice, particularly for performance engineering, has a massive impact on how quickly and effectively you can get quality built into your apps before they hit that production environment.
Excellent. Thank you, Brian. Next up, joining us from Vancouver now, but not always in Vancouver, sometimes in Australia, is the one and only Liz Fong-Jones. Liz, welcome.
Good day, everyone. I'm Liz Fong-Jones. I'm the field CTO at Honeycomb, which is a startup in the observability space. And I also am a former governance committee member of the OpenTelemetry project. And I've been helping people with their SRE, DevOps, observability journeys for the past 20 years.
20 years, wow. Excellent. Our last panel member is a good friend of mine. She's also been on this show with us over the years several times. Chensi Wang. Chensi, welcome. If you wouldn't mind introducing yourself.
Thank you. I'm not going to count the number of years I've been in tech.
It's probably been 5 or so.
So I have a background in cybersecurity, did a lot of work in cybersecurity, as Alan knows. And in the recent number of years, I've been doing more in DevOps and SRE. And I'm the founder and general partner of Rain Capital. We invest in early stage tech startups, and I'm an investor in Stanza, which is SRE as service company. And many of you know the founder, Niall Murphy, and we've been doing a lot of work in this space. Very excited to be here today.
Absolutely. We're very excited to have you here. And then last but certainly not least, I don't consider him a part of the panel. He's my co-host for DevOps Unbound. He's also our CTO here at Techstrong, as well as GM Principal Analyst for Techstrong Research, my friend Mitchell Ashley. Mitch, welcome.
Great to be here. I feel like this is a friends and family panel. They're all folks that we know really, really well, and super thankful that you're here with us today.
Absolutely. All right. With that being said, that was a long-winded way of introductions and setting the table, but let's jump into things before we go again. Use chat, Q&A. Let's hear from you. We want to hear your questions, comments, thoughts on observability in all of its many shapes and sizes and flavors. But I wanted to kick things off with Chensi. Chensi, you recently wrote an article, was published over at Alex Williams' Insight Partners, New Stack, and talking about sort of a new era, a new way of looking at observability. Why don't you tell us what you meant?
As you pointed out, observability has been a very active area of innovation in the last 2-3 years. Now, I'm glad to see that, and also glad to see a lot of people interested in deploying sort of application measurement and OpenTelemetry, these mechanisms to really measure the performance and internal state of their applications. However, what I'm looking at is how observability can better serve really the end state, which is making our product, our application, to be more effective and serve the users better. To that end, I advocate that in the within the larger context of observability, that's a hard word to pronounce.
Sometimes it gets me too. I know what you mean.
Within the larger context of observability, we should focus on critical user journey, which is a slightly narrow scope of how users really interact with your application and your product in a way that really impacts your business, right? So an example of if you're an e-commerce site, then checking out the shopping cart is part of your critical user journey. Now, displaying other related product may or may not be part of that critical user journey. Under extreme load, what you need is to really focus on how your product is performing as part of the critical user journey. And that's really the crux of that article. And I'd love to talk a little bit more about it with our panelists today.
Absolutely. So Brian, we were talking sort of in the green room or waiting room before we started, and you were really jazzed about what we were talking about today, because you said it's about 40% of your day is spent in there.
Yep. The general gist is, when we talk about the quality engineering effort as part of application delivery, there is this idea that we want to make sure that the application is functionally correct. That's relatively straightforward from a testing perspective. That's very binary. Either it works or it doesn't. Either something got added to the shopping cart or it isn't there. But performance is much more nebulous. It's a lot fuzzier around the edges of what constitutes success or failure from a performance and scalability perspective. And when you're looking at performance test result sets, you can see, typically 10 million, a billion data points in that range. You collect a lot of data running a performance test. When you tie that into observability solutions, whether those are APM vendors like Dynatrace or Datadog, open source solutions like Prometheus, a way to collect detailed understanding of what's going on in that system across our customer base, we find that the time spent analyzing performance results to figure out, is there a problem, drops by about 80%. And the time to remediate a problem once you know it's there drops by about 95%. It's a staggering improvement to the velocity of your quality engineering effort to tie observability solutions into your performance testing practice. I can't recommend it enough. It's outstanding what it does. It's transformational to any quality enterprise that you're participating in.
If I may interject as well, when you think about it, like when you're writing software, if you're already instrumenting your code, right, so that you're making it easier for the folks who are on call to troubleshoot your software should something go wrong, why not take advantage of that earlier in the process? Like, why not use it, say, as a quality gate for your QAs, right? Where your QAs can go in. And so even like before performance testing, which I totally agree, like super important, but even like when you're getting into like your QA phase, your QAs can say, okay, this information is here. Like you've instrumented your application. That is a quality gate. Or even your QAs can use the telemetry emitted from your application to go to the developers and say, hey, I know what's wrong because I'm using that for troubleshooting. I can tell you what the problem is. And if they can't tell what the problem is, then it means that your application has been under-instrumented, which again, you can go back to your developers and give them that feedback.
Yeah, as simple as saying things like build 79 is consuming 40% more CPU. What happened? Right? Why is it suddenly so different? And that comes from having the ability to look at this data over time and trend it. And that is a hugely impactful layer of visibility and transparency. I think it might also be important to differentiate between monitoring and observability for the audience.
Yeah, we haven't level set that yet. We probably
Exactly.
should.
Like, monitoring is watching a system to try and understand what events are important. You collect everything and you got to filter through a lot of it. Observability is really an instrumented approach where the application will tell you about important events that are occurring. So it's they're closely related. There's a lot of overlap, but they're also very, very different conceptually. They have a different origin point. And
yeah, as my boss charity major says, it's about monitoring is about known unknowns, monitoring for when your system, gets out of certain bounds that you knew about in advance. And observability is about unknown unknowns. How do you, to borrow Chenji's point about critical user journeys, your critical user journey is broken. You don't know how or why. How do you debug that? How do you figure that out as quickly as possible, even if it's a unknown condition that you couldn't have predicted in advance?
And I would say that, in the spirit of shifting left, it's harder to instrument your code when it's already in production. It's a lot harder. And sometimes it's impossible to instrument your code. So if you can instrument it before it goes to production, it's magnitudes more effective and saves everybody's time.
Yeah, you don't have to boil the ocean either, right? Like you don't have to say, oh my goodness, right? Like we have to instrument our entire application. You can just make your application better with every single pull request. Like at Honeycomb, we have part of our pull request template that says, what is your observability plan, right? Link a graph or link something that will change as a result of this pull request. And if you just do that one pull request at a time, you'll make your code base much better.
So I would say that it's a really great thing that you guys are doing that. What's the uptick from developers? Because, coming from security, we have similar problems where, we want people to develop secure code to begin with, right? Not wait until it's in production. But we've been at it, Alan, for many, many years, and we still see that ton of, flaws make into production. Sometimes because they don't have the right tools. A lot of times because developers don't care enough. So those of you who work in this area for longer than I have, how do we get developers to care more and do more?
so
One thing that I've seen is, so I'm heavily involved in the OTel end user working group, and one of the folks that I interviewed last year, who's they were just starting on their observability journey in their organization. And one of the things that her organization did was, first of all, they were a very observability forward organization. So the folks up top were already mandating those good observability practices, which makes such a huge difference, because one of the things that they said, and I think Liz will definitely appreciate this, which was basically, developers have to instrument their own code and not run to the, there's an observability team at this organization, not run to the observability team and get them to instrument their own code. So having that already support from up top really helps. But also then you also need the folks who are really enthusiastic about observability, who are going to be rah observability, to make this happen and make it kind of an infectious thing at the organization. And this end user who we were interviewing, she was so into it. So, having people like that makes such a huge difference. So that convergence from the top and the bottom.
Yeah, you really have to have a community of practice. But my experience is that one of the really great things about observability, and security, unfortunately, sorry, Chenji, right, is that with observability, you can see the number go up and to the right? You can very clearly see the impact of your change. And that's a thing that developers become really addicted to, right? Is that dopamine hit of I shipped something, it reached production, I can see my code running in production. I don't have to, be oh, the build number matches, now I go about my day. It's I can see the effect that I had in the world. That's really cool.
So I think that's great. But my experience, a lot of developers have very difficult time understanding how to instrument their code, and especially for observability, right? So one guy told me that if they were to instrument for observability, more than 50% of their time that devoted for observability instrumentation is figuring out how to instrument rather than actually instrumentation. So, and one of the things I'm really excited is to see there's some innovation that's coming out that's using LLMs to understand the code and say, okay, now we kind of process the code, we can suggest or recommend the best places for instrumentation for observability purposes. It's still early days, but I'm very excited about that.
So, and this plays into a couple of industry trends that I've seen over the years as well. When we talk about agile from a agile purist perspective, not a reality of how it's actually implemented, those teams are designed to be cross-functional. They're designed to have expertise with observability platforms, potentially as a team member who's there to assist and help that particular agile team implement this stuff, so that not everybody has to learn it from scratch. But it's also really as simple as, to get the developers to care, add it to the backlog. I mean, fundamentally, I see this when in every shift left conversation that I'm having with customers about moving the quality process earlier in the life cycle. First, shift left doesn't mean make the developers do it. Break that mindset. The developers have a job. They presumably enjoy their job. I hope they do. We're talking to the QA team members now who need to learn things like what workflow code is in a CI system, what a source code management repository is, and how to check their test assets into those. But getting it into the backlog, just as an item, a task that needs to be completed in order for the sprint to wrap up. If it's not present, then the developers don't care. That is it. I find that to be the simplest, easiest thing that nobody likely needs to buy any software to do. You probably got these systems already. It's as simple as just putting it in there, saying, include some observability in your code. Here's a template that you can use or something, and see what happens. I think you'd be surprised at how effective your developers are at implementing this kind of stuff.
I really don't love the eat your vegetables approach, but I do think that there is an element of kind of peer pressure and shaming in terms of, you wouldn't check code into production with, into the main branch without comments. You wouldn't check in code without tests. Why are you checking in code without observability, right? Like, either way you slice it, you have to get the observability in there, whether it's with every pull request or just as an item in the backlog. That's kind of a gate, right? Like, yeah.
Interesting. I've seen sort of all shades on the spectrum, right? And I'd love to hear a little bit more about on the more advanced. And we talked a little bit about incentives, right? How getting into the backlogs and potentially it's one of those metrics that evaluate team performance. I'd love to hear a little bit about interesting technical solutions that scale up observability practices. And anyone has any interesting best practices?
So from an implementation perspective, you can certainly look at packaged software solutions that have insight into the systems under test. Whether those are things like Datadog or Dynatrace, they're kind of the two titans in this space. From an APM background, but they have a lot of observability stuff where they can consume traces and consume system metrics and all sorts of things to give you that insight. I don't find those systems deployed into pre-production spaces terribly often because there's a
it's
cost.
Because they're licensed per seed or they're licensed
it's
like post. Yeah,
potentially to put that stuff out there. So there are open source solutions for this, notably Prometheus, but there's probably dozens of others that are out there that provide a very convenient placeholder for you to put this type of information as your system's writing this stuff out. It's great to have the observability data. You need an effective way to consume it, in particular to trend it over time. Using those types of systems, I think, is probably the correct approach so that you can view the data easily in the right context.
This is actually one of the cool things where, Adriana and I mentioned that we work on OpenTelemetry, and OpenTelemetry means that you can use the same code, use the same SDKs, and use potentially, as you're saying, different tooling in test and in production, right? One of the cool things that we've seen from the OTel user community is someone implemented a local, like, OpenTelemetry daemon that literally prints out, like, in standard out, like, every trace that it receives. So you can look as you're running your test or as you're running your code and seeing what's spewing out without having to send it off of your machine. It's really cool stuff. And I think that's kind of how you get people over this hump of, oh, but I want to develop locally, right? Like, I can't be sending that over to.
And there's also like a storytelling or education aspect of appealing to the selfishness of the teams as well. If I'm a developer and I write code and I check that code in, the last thing I want to do is be told 3 weeks later that it doesn't scale or perform properly and I need to go back and revisit it. That's not what I want to do at all. I'm already invested probably 2 sprints later at this point. So talking about this as a best practice, as a mechanism to avoid having that happen. Your code doesn't come back because it is built inherently to expose all of this stuff. And if it doesn't scale, we'll tell you within minutes or hours, not days or weeks.
And it'll only take you 5 minutes to figure out what's going on and not 2 hours.
Exactly.
But we also need platforms or instrumentation measures that are easily integrated with the tools that developers are using, right? So sometimes, part of pull request is great. An SDK is good, but then a lot of people say, for me to integrate, now let me finish. In order for me to integrate with your SDK, man, I really, really have to understand what's underneath there, because if I'm going to integrate it into my code and it's making, I don't know, millions of dollars a minute, I'm going to need to know this thing to the death, right? So
you're making an excellent point about context here. If we just tell the developers, make your code observable, write it out into something like, I don't know, Dynatrace. Dynatrace is built for IT operations teams and monitoring teams. It's not built for the developer community. The tool isn't fit for purpose. So yes, I can force the developers to use it, but they're going to hate it. The same way that I get a lot of pushback from QA teams when I tell them, I'm sorry, you're going to have to learn about Jenkins. Well, they hate it because it's not built for them. It's built for that DevOps developer community. The times they are a-changing, but we have to put that information into a consumable format that's convenient for the audience that's going to be doing the consuming. And that is still, I think, an outstanding problem in the observability space, that the information is difficult to present in a way that is relevant for the stakeholders.
I see now why we're disagreeing about whether, please submit a graph that shows the change is a carrot or a stick. Because if you have a tool that's a delight to use, that developers love to use, that they can easily navigate, I see how it's a carrot as opposed to, eat your vegetables. But that's not necessarily true if someone's forced to use a legacy tool to, pull up the graph and they have to learn esoteric things. So yeah, right. Like it's about the outcomes, right? It's about developer productivity and not, are you collecting the damn signals?
Yeah. And
but
how many teams do you see that are things like the QA team and the dev team are at odds with one another? That's crazy. You're all on the same team. You're all working towards the same goal.
One thing that I wanted to mention, because it's something that keeps coming up in the end user working group here and there, is some people find, like, for example, for instrumenting your code, they find the learning curve for using something like OpenTelemetry a little too steep for them, right? And that can be a barrier to adoption. And one thing that I've talked to a few practitioners about is that they actually write wrappers around OpenTelemetry so that they can basically have something to hand over to their engineers that it's like, here, this thing is relatively easy to implement. And this can be also like really helpful if you're going from like a different instrumentation library, so that it makes that transition a lot less painful. I don't know if anyone else has any thoughts around that.
The number one thing that people can do, right, like is they can just go from, debug printf to, span add attribute key value, right? Like when you start structuring your data, even if you still think about it in your head as, it's a log, but like as long as you have the key value pairs, that's the important thing, right? Like, creating the trace spans, right? Like you shouldn't have to worry about creating the trace spans. That is our job as OpenTelemetry mostly, right? The auto instrumentation should take care of that. So really, from a developer experience perspective, my wish is, and I know it's not always the case today, but my wish is that people only have to think about what key value pairs or like, what strings do we want to appear in my output? That's all they should have to care about. We already know how to printf debug.
Yeah, I hope that's the case, but it's not the case today. And Adriana, you're right that OpenTelemetry is a little steep in terms of learning curve to adopt, and that is a barrier. And so are a lot of other tools today. And I think that's partially because we're early in this market, right? So tools will mature and practices, mindsets will mature. But one of the things I also want to point out is it's one thing to tell developers to put this instrumentation in your code and emit telemetry and whatnot. there's a analogy I want to draw here between unit test and sort of the integrated test, right? So you can emit a telemetry from your piece of code, and he can or she can emit a telemetry from their piece of code. But all these things together has to stitch together and give a higher level context for how the whole application is performing. And I feel like the tools today don't necessarily help you do that very easily. And that's one thing I would love to see us innovating.
In the quality space in particular, for automated functional tools, I have yet to really see any tools that are capable of consuming telemetry data like this. There's a few basic monitoring integrations that I've seen, but for the most part, they're not focused on the behavior of the system or any signals the system itself is emitting as a quality metric that they can consume. The performance world's a little different. The tools tend to be much more flexible. As long as it's a time series data set, I could pull it in. So if I have a list of telemetry points, we usually use something like a Prometheus platform as a go-between. Write it out to Prometheus, we can consume it from Prometheus and overlay it on top of the test results. But that is still vanishingly rare to see in most implementations.
And that doesn't give you an explanation of why things are happening, right? Like that tells you that, you push the system to its breaking point. Here's what the breaking point is. But wouldn't it be really nice to have that correlation of here is the critical path, right? Like here is the thing that broke under load. That's your limiting factor.
Yeah, that's why I wrote that article. I felt like we are, lots of time we talk on different levels, like business people's here and our developers here, our engineers here, in the sense that engineers, we're doing a lot of things. And the business people are like, we don't get enough information to make decisions. So like, for instance, we can instrument our server side code and we can say, the requests, I don't know, 10,000 per second, the response rate is such, right? It's below what we wanted. But we don't know which user on that end is seeing this response because we have to stitch things together. And the stitching together is what gives that business context. And anyway, so I've been looking at that problem a lot, is how do we go from lots and lots of data to really give you that business context across the performance of across the interactions of your application, right? It's critical user journey.
Yeah, I think that's the thing that, both Adriana and I work on in our jobs very much is, we want the tools that we work on to support developers in achieving those outcomes and really thinking about, how do you analyze things, as you're saying, per user. I did want to turn our attention to one other thing with regard to testing and observability. We've talked about adding observability to code under test. What about observability into your test performance? The number one thing that makes people reluctant to add more tests, add more integration tests, et cetera, is that they're like, it's too slow, it's too brittle. Wouldn't it be nice if we could, figure out how to cut our build times and cut our test times?
This is a fascinating area that a lot of quality vendors like Tricentis are investing time in, which is when it's time to do a QA cycle, what tests need to be run? How much time is being wasted running tests that are completely unnecessary based on the code change sets? Whatever that change set is, it can be tied via CI to what the assets that are being deployed. And if I have a way to understand what assets are deployed when I execute a transaction, what lights up in the back end, I have this association of if something is changed in code, I know what that's going to impact in the production system, and therefore what tests execute that particular functionality. And I can focus my efforts much more exactly on the things that matter and only test the things that are changed. That doesn't eliminate the need for full regression tests because software is weird. I don't know why touching module A has now broken module R, but here we are. But nonetheless, I can dramatically shorten a lot of QA cycles that are attached to CI pipelines by making them very targeted and very quick. And back to that whole idea of a continuous quality effort of just constantly barraging every change set with a series of tests that are relevant and on target.
And I think this brings, I was going to say this makes me think of two interesting related topics. And one is the observability of our actual CI/CD pipelines, which I think we all agree we need to do. But when you go look at the tools out there in the market that should support that, it's really kind of I don't know, it's not standardized. Like Jenkins has a plugin that lets you do that, and I think Tekton has a plugin that lets you do that, but like, you know, there's no like official GitHub action. There might be in the works some stuff around GitLab, but like we don't have that unified, you know, CI/CD observability, which I think if we had that, we can definitely it would give us those greater insights as well.
That sounds like a fun little project that someone should work on, right? Especially given OpenTelemetry is vendor neutral. There's no, you know, this is bound to this one specific vendor. We can't put that in Jenkins, right? Like you can and should put OpenTelemetry into Jenkins.
Yeah, I mean, I think that will happen, right? So again, coming from security, you know, we've seen lots of security for code. And then in the recent number of years, we've seen security for CI/CD pipelines. So configuration of CI/CD pipelines, access to certain stages of CI/CD pipeline, all becoming part of your application security strategy. So it will happen here. But I want to ask a different question. I think, you know, we all of us work a lot in this area where we're trying to look at support for developers, for testers, and in production, how to do better observability and lead to better quality and reliable code. Because as Brian pointed out, software is weird, right? So it's like you touch this module and that module breaks and nobody knows why, and spend a lot of time, then you figure out why. In the future, really is, you know, AI is writing code for us. Most of code's written by AI. Will we still need this level of this type of low-level tools to help us do observability and testing? Or do you think it will be complete changing in the requirements for this?
Oh boy, is it going to be completely different when this finally gets good at writing code. AI, looking at it from a testing perspective, can I get an AI language model to write a test case today? Absolutely. I mean, knock it out of the park, because I'm giving it the specifications of what needs to be tested. Can I get it to author a test suite? No, not at all. Does not have the context or understanding of the application, the critical path, the user scenarios that it needs to have. But that's like January 2024. I don't know what February is going to bring. It's changing very quickly. And the ramifications on development, QA, application delivery are going to be profound at every single level of the software chain. We're going to see the reduction of the low-level understanding of what's going on, because that's what the AI system is going to deal with. And we're going to move to a much more executive function.
That terrifies me. I am noted as an AI pessimist, and I believe that we are setting ourselves up for a lot of leaky abstractions. Sure, the AI, you know, can perfectly abstract this until it doesn't, and then a human being is responsible for debugging and figuring out what went wrong. And if AI is enabling us to write a lot more code without understanding any of it, that's going to be a really painful wake-up call. AI is not.
Hopefully, we teach the AI system to put in comments.
I mean, I think that's if you take us back, I don't know, 40, 50 years, the same argument with, you know, people used to write assembly code, and now you write high-level language. You're like, oh, I'm so scared because I don't know what the assembly code is doing. I think it will be the same thing.
The way I look at it is I see AI more as like an assistive, you know, it's a trust but verify. AI can say, hey, this thing here looks kind of neat. Maybe you want to take a look at it. But you still need that human touch to really determine whether or not it's something worth looking into. But would I trust AI fully with my systems in that way? I don't think so. I don't think we should. One thing I would love to see in AI models, which I don't know if we can achieve that, is having like that non-biased take on things, so that we can, so it can, you know, in a non-biased way, point things in our direction. But I don't think that we're there quite yet. But that's what I would like to see.
Today, that is the case. Because Today is a co-pilot assistant.
Yeah, for sure.
I'm not sure. And being biased, I think we're probably never going to be completely unbiased.
Yeah, I know, right?
Your metric is none of us as humans are completely unbiased, right?
Exactly.
An AI to be completely unbiased. So I think we can live with that. But the interesting thing I'm looking at this is with the advent of AI and how fast that field is moving, how much disruption it brings to software development, software testing, and reliability field as well in general. And it's all very fascinating. And sometimes I sit here and then look at some of the work we do, and I'm like, would it matter in 2 years, in 5 years? So that's a very interesting question to ask.
That's a trend that we've seen in the education space, where students in computer science programs are learning languages that by the time they graduate may be defunct. I don't feel great about that, but that things are changing faster than I think we're going to be able to start keeping up with. And that's where we're going to start to see that executive function. I'm with Liz. It kind of scares me of the layers of complexity that I'm not going to understand. To use an analogy, if my car didn't start, I would look at it and maybe check to see if the engine was still there, but I can't address any other issues beyond, well, there's wheels and an engine. I don't know. I think we're going to start getting to that with software.
I love if we get there with software. I don't understand anything about my car, and I drive it every day. And I love to do that with software someday.
Well, I think that's an inevitable progression.
I hope I live that long.
I think you're going to make it another year, Alan. We're going to see that.
I drive what's supposed to be a very technologically advanced car, and I'm baffled every day, man. I wind up having to go on YouTube to figure out how to do things.
Me too.
And now we have software updates that are bricking cars, so that's also very exciting and terrifying.
We're doing an update. I pull over because I'm afraid to drive with it, but I don't even want to. Guys, I'm sorry. Go ahead, Chance.
No. I was just going to take us on a tangent on cars, so I'll stop.
Cars and observability. It's kind of like a show, riding in with comedians in cars or something. I don't know.
Did I tell you my story of buying a house on the car?
No, you didn't.
It's a good story. So a number of years ago, I live in Silicon Valley, right? So we do a lot of things online and stuff. And I was driving to the airport with my husband on a vacation, having just put in an offer on the house. And my agent called me, said, hey, I need you to put a counter offer. If you do this level, you might get the house. And we're like, you have to sign the offer. And we're in the car, right? And she's like, I'm going to send you the DocuSign. And I drive a Tesla, and I've got a big screen in the car, right? And I'm like, okay, send it to me. And I pulled it out on my Tesla and signed the thing. And probably over an insecure SSL at the time, right? And so that was my, and we got the house. So it's my story of
and 5 years from now, someone may come by and say that was somehow wrong and it was fraudulent and what? Yeah.
No, that was. I'll tell you, that was 10 years ago. 10 years ago, I did.
Well, the statute of limitations is up, right? You know what, guys? We've had a tremendous panel, and we haven't. I didn't want to interrupt. I apologize, but we've had so much good stuff going on in our audience, and people making comments and questions and contributing their thoughts. And I'm not gonna have enough time to hit them all, even. But one thing I did want to mention is I think Brian, you and a couple others tried to answer this in the QA part. Someone wanted to know all this observability data, even that we're using sort of in the CI/CD process. It generates storage, and you gotta
be saved somewhere.
That's right. And I mean, look, quite frankly, that was always what we would hear from the gripers around Splunk. Is it and now, Splunk was observability before observability was called observability to a certain degree. But that was always the thing. It's so damn expensive to store it all. So now I got to pick what I want to store and what I don't want to store, or what's not worth storing. And it's not just a Splunk issue. It is a observability issue. It's an internet issue. This is the old story. When I first started getting computers and all my data was on the 5 1/4 floppy drives or cassette, even before that. And then the 3.5, and then I thought I had 20 megabits. What would I do with 20 megabit hard drive? My God, now terabytes aren't enough. What's the answer here? You're not store.
If you listen to the observability vendors out there like Datadog, or it's better to collect it and not need it than to need it and not have collected it. Of course, they do all charge based on how much you collect.
They charge you on volume of data, so I think we'll have to take a grain of salt.
Grains of salt, exactly. Yeah. But there is a lot to be said for having a wealth of this data in storage capacity. And yes, it does potentially get expensive, but
if you're talking about, a lot of those data platform vendors, data lake vendors these days, you can put things in there, but the minute you take data out, they charge you per egress, and you're kind of scared of using your data. And what's the point of having it if you're not going to use it? And you run into this state of what I call data obesity. It's like, does nobody any good, I think.
I think part of the data in the world doesn't matter if you can't analyze it.
Exactly.
I was going to note a couple of things. First, I think one of the pitfalls of that folks fall into when they start instrumenting their code, is getting into auto instrumentation, which is wonderful if your language supports it. But there is such thing as too much instrumentation, and going bonkers on auto instrumenting all the things because it can all be auto instrumented is not going to do you any good, because garbage in, garbage out. You have a lot of crap data. How are you going to sift through it? So I think that's something that folks still need to be aware of, and maybe the fact that you keeping an eye on how much you spend in sending your data over to an observability vendor, maybe that's a good thing, because it kind of forces you to be a lot more mindful of the data you're sending. Don't send everything into the kitchen sink. Send what's important. Mind you, it will. I think it's going to be a bit of an iterative process to figure out what's important. So it's there's no perfect answer, but I don't think we should just send everything for the sake of sending everything and just end up with a garble of information that we can't sift through.
I have a question for the panel, if I could. It seems to me there's an intersection here when we're talking about development and even test adopting observability technologies. Seems it kind of fits well into the developer experience category, something we see in platform engineering and areas like that. Are people investing in that, thinking about part of our developer environment, the things that we're creating, our portal, whatever it might be? Is observability one of the tools people are figuring out how to make that more ingestible, usable by developers and testers?
We're starting to see this trend, right, of SREs, of DevOps, CI/CD teams, and observability teams all coming under the platform engineering or platform team umbrella,
Yes.
which I think makes a lot of sense, because we're serving the same audience, right? We are there to make developers' lives easier and to make it possible for them to run their systems.
Yeah, we see that too. And it used to be SRE teams. Now it's migrating to platform engineering and having broader responsibilities, which I think is a good thing. Totally in agreement here. But I think in terms of developer experience, I don't know how many of them are calling it observability for developers per se. It's instrumentation. It's like test aiding, that kind of thing. So I don't know if that concept specifically is making into the developers' world in droves.
I don't disagree.
Great, thanks. Maybe that's an area where we'll see some good progress, and let's hope.
Let's hope.
I mean, I hope so. Right? It's exposing to the developers those trend lines of how their system's evolving and changing over time in a format that they are able to consume and correlate with their effort.
I think
Would be amazing.
It's interesting. One of the things I know from building security products, many things developers are good at. One of them is detecting when a piece of software has not been built for them by people like themselves. I can tell when a security tool is built for security people, not developers. We kind of have that problem with observability too, right? How do we make it more built in the model that a developer could easily use if they expect it's got APIs and scripting and all kinds of things that they like to do with software?
so. I think the whole. I don't know how much you guys pay attention to the sort of feature flag work, right? So that whole segment of work, I think it's a little bit more geared towards developers, and just so I'm hoping our platform engineering and testing work could learn a little bit from that and potentially becoming more developer friendly.
Yeah, one of the fun challenges of feature flags is that it introduces massive dimensionality and cardinality, right? Like you no longer have one configuration that your site is in. You might have the combinatorial explosion of 10,000 different configurations. How do you figure out which feature flag is influencing the performance and behavior? And that's where I think observability and feature flagging really interlock and work really well together.
Yeah, agreed.
Guys, we are coming up on the end of our hour. There's still so many things that people ask and talk about here. Just real quickly on the car thing, though, Elizabeth had a great comment, which was, I don't have an Alexa or a Tesla. I still have a car. I can use the mirrors. And there's something to be said about, I know how you feel about that. I just don't, we're going to try to, Cody is our person who manages the back end of our big marker. Cody, if we could grab a lot of the questions and comments, perhaps we can get it out to the panel members after the fact and try to get some answers, or we'll put up along with the replay of this some of the comments and questions and answers with it. I also want to point out, if our audience members, and first of all, thank you so much for the comments and your input. If we didn't get to it on here, it's not that it's not valued. It is valued, and I learn more from watching what you guys say than sometimes listening to our panel members. But anyway, if you would take a moment in that communications window again under handouts, the very first thing in handouts, and of course it's not there right now. Oh yeah, it is. It's the 1-minute survey. We constantly try to make these things better and more interesting. And the only way we learn is, well, people vote with their feet and their eyes and their clicks. So when you register and come to these events, we assume we're doing something right. Well, we'd like to know more about what we can do to do it right. So if you can take this, it's just literally is a 1-minute survey. If you can take it and submit it, we appreciate it, because it helps get us more in tune with what you want to see and hear and do. And actually, Cody's put it right in the public chat too, down on the bottom. So if you wouldn't mind taking a moment and filling that out, I would personally appreciate it, as would our whole team here. Guys, we've got maybe 5 minutes. I want to give each of you a chance to sort of wrap up final thoughts. And let's go in the order I introduced you, which is Adriana, Brian, Liz, Chency, and then Mitchell. So Adriana, take it away.
Final thoughts. I think at the end of the day, like, this is making observability part of, shifting left on observability is the direction that we absolutely need to go in. I do want to give a shout out to something that we didn't have a chance to dig into, which I think is worth mentioning, which is trace-based testing, which is the idea of you're instrumenting your code anyway. Trace-based testing lets you take your existing instrumentation and write integration tests. So I think that's a practice that I would love folks to get more into as time goes on. There have been a couple of vendors in the past that have done trace-based testing. So like ones to check out, like Helios, Malabai used to do it. I don't think they've updated that project for a while, and trace tests. So just wanted to mention that as well, because I think it's very important to our narrative and really bringing observability into the SDLC.
Excellent. Brian, how about you?
Alrighty. If you tie in observability solutions of any sort, whether you're just writing to standard out to a CSV file, whether you're using a paid solution like Datadog, anything along those lines, your performance engineering team will thank you profusely, because it makes their job spectacularly more efficient and faster. And that makes everything better for everyone, especially you developers, because you're going to learn about any performance or scalability issues in your code within minutes or hours, not weeks later.
Excellent. Liz, I think you're next up.
Yeah, I would say the first and easiest place to get started is just to wrap OpenTelemetry around some of your testing suites and speed those up. OTel CLI is really great. It basically allows you to wrap a single command line and send a trace based off of that, so you can bake it into your CI/CD system and make your tests run faster. And then that buys you a lot of leeway to do a lot of really cool other stuff.
Yeah. Excellent. Chancy?
I think it's in agreement that we should shift left in terms of observability. I also want to say that while we're thinking about instrumenting your code, as developers, as engineering teams, considering this, there are multiple different places that you want to think about instrumentation. Server-side application is one. Edge proxy code is another place. So even closer to application proxy like Envoy, you can instrument there as well. I don't know how that translates into testing per se, but there are different places that we could do those instrumentation will help you with performance engineering and development as well. So.
Absolutely. Mitchell, you want to take the last word and bring it home?
You bet. Well, first of all, great panel. I just sat back and chatted and listened, and it was fantastic. While I don't think AI generating all of our code is going to be here tomorrow, it'll be a series of increments to getting to whatever that place looks like. We already are using like generative AI to find bugs in code and help us instrument code. And maybe we need an LLM that helps us make our code more observable or more manageable. And we can find new ways to leverage AI to help us build observability-driven code. Let's look for that. Back to you, Alan.
Excellent. All righty. That's going to take a wrap on this episode of DevOps Unbound live roundtable. Again, thank you so much to our audience. I can't thank you enough for all you guys do for participating. Just coming on is appreciated, but participating is amazing. To our panel, we're doing this 3 years. I've done, and this isn't the only show I do. We do a lot of panels. I love it. It was a panel where I have very little to say, and I just, you guys just take it away, and you certainly did. And it was just an amazing discussion with some great opinions, great thoughts, great intelligence. And if I had to put one word on it, I would say this was a really intelligent panel. Thank you all very, very much. Big shout out and thanks to Tricentis for, as I said in the beginning, being here from day one with us on DevOps Unbound and continues to be here. We'll be announcing more with Tricentis, I guess, in a week or two as we continue our affiliation. We're excited for 2024 and working with them. You'll hear more. Mitch, thank you very much for all you do as always. But for now, that's it for today's show. This is Alan Schimmel for Techstrong Group, Techstrong TV, DevOps Unbound. Thanks for joining us, and we'll see you soon at another event.
Bye, everyone.
Bye.
Bye.